the homework due tomorrow, but it's only half of the section. It's only half of the section. We're splitting it into 2 different pieces. So there is a homework I just posted online. It is due tomorrow, but it's only half of a normal homework. It's only half of the section. There's a reason why, though, so just trust me on it. You guys don't mind. You're in the back of your homework spiral doing a practice problem before we grade our homework. The one that was due over the weekend. What was section 3.1 on? Exponential functions. Exponential functions. What's in the base? A variable or a constant? Constant raised to what's in the power? A variable. It could be an x, it could be an expression. Mickey, what's that?
So for our homeworks, do you want us to make like 2 different tables?
No, don't worry. Oh, a table of contents. Yeah, but it's just homework 19 and homework 20. Okay. So it's not a big deal. But one's technically 3.2a if you're labeling it, and the next one's 3.2b.
Okay.
Yeah. Got it. Okay, so you guys in the back of your homework spiral. Algebra 1. Because I literally just taught exponential functions like a chapter ago. Almost all of them on their quiz, because they take quizzes before their test and then they get to do makeup quizzes and all this jazz. Almost all of them would have done this. Why is that horribly wrong as the first step? Yes, they would have written this on the other side, and they would have freaked out because there was a fraction, but they wouldn't have had one this hard. But a lot of them would have made that 6. Why is that illegal? Raise your hand, raise your hand. Nathaniel, why? Yeah, PEMDAS. It's old-fashioned PEMDAS. Exponents have to come before multiplication. So as soon as you try to make 2 times 3 to be 6, you just jump the gun, multiplication before exponents. And here's another rule. You cannot combine exponential expressions unless they have like bases. 2 is not 3, 3 is not 2. I can't combine. It's impossible. It's illegal. So therefore, if that was not the right one, I said it verbally, but some of you guys aren't really like verbal processors. So for those of you guys that did get it though, if multiplication is not the right first step, what was the right first step? Division. Yeah. If I can't multiply, well, I have to get rid of, deal with that 2 somehow. The nice thing is once you divide, you end up with 3 to the 1 minus x equals, and over here the 2's reduce. That's the proper term. They just reduce. 1 over 9. What's the goal? Most of your homework would have been easier if you were solving. What's the goal anytime you're trying to solve for x in an exponential function?
Get it right.
Well, get x alone, but how are you going to get it out of an exponent?
Square.
That's what some people think.
Oh, no. You just set the bases.
You gotta get the bases to equal. You can't really set them because it's already an equation, but I want to make the bases match, right? Now, technically, once we get a little further, remember this whole chapter is all about puzzles. It's all about trying to learn the rules and use the rules legally to get what we want. In this one, we want to get to x. It's like a very introductory puzzle. It's a very introductory equation. We want to get to x. That's our goal. What are the rules? Well, the rules are I had to deal with exponents before multiplication, so fine, get rid of the multiplication. Now I want to get to the exponents, but I can only do that right now if I make the bases match. Think about it, those of you that didn't already get there. But there is something to do with logarithms, and logarithms can undo exponentials. There are other ways of getting up there. But for right now, at this level, in your homework, if there was a way to make the bases match, that is by far the preferred method. Now, in my mental math, if you guys are curious as to why I got it wrong, in my head, I went ahead and added the 2. So I was like, oh, 3 and the negative x is negative 3. My bad. I didn't add the x to the other side. Or I didn't think about negative x equaling negative 3, subtracting the 1. But yes, you do end up with x equals positive 3. But Nathaniel, I heard why. What's the one you asked? Someone said why just a second ago. No? I just wanted you to say why. Question.
Why?
Why is it the negative 2? Not everyone's tracking on this. We could rewrite this as 1 over 3 squared. And a negative is what results when rewriting a fraction. Another way of saying it is the negative exponent displaces the power. The power is the 3 squared, so negative displaces it. Right now it's technically in the numerator, but the negative would displace it to its denominator. I can go backwards. Who beat me there? Which groups or which individuals? Who got x equals positive 3? I got it. Didn't just hear me say it. Here's the sad thing. I think almost every group had at least one person that got it right. So where's the breakdown? What were you supposed to do? Talk. Not just you do it, but check that your whole group is on board. Now, maybe you tried to convince them, and they were stubborn, and they said, no, we have it our own way. Maybe. But what's the higher likelihood? What's the better likelihood of what actually happened? You didn't talk. Okay, you're in new groups. You at least hopefully said hi to each other this morning, but what are you actually supposed to do in your groups? Well, okay. Danger. I shouldn't be telling period 3 pre-calculus this year to talk more. That's not so much the goal. What's the goal? Not to talk, but to work together, right? When I tell you to talk, when I tell you to work together, then do that. But otherwise, all the extra chitter-chatter that has nothing to do with math, maybe we need to cut that down a little bit. All right. Productive talking versus non-productive talking. So we have a homework. We need to grade that homework. But first of all, you guys probably saw some E's in your homework. So stay in the back of your homework spiral. These are easier than the one that you just saw. Bust it out real fast in your groups. What if you saw these ones where the E's make a huge difference? Solve for X in both. Ready, set, go. And this time, I don't want to see someone getting it right and their whole group didn't. It should be fast, though. These are easier than the one that you just, or the one that you just saw. Is that bad?
No, not quadratic. There could be two X's.
Think -2 and -3. You're welcome. Hey, did the E's make it harder? Yes or no?
No.
Not at all, because what was the point? What matched? Perfect. So all we had to do is 3x plus 2 equals 3. Simple algebra, which is sometimes not all that simple. Did any of your brains want to say 3 even though it was 1/3? No? Did any of us eventually get to where we needed to solve that expression?
Okay, that's right.
I love the ones with 6s and 5s because it could be 6 and 1 or 2 and 3. It just depends on what the signs are. This one was a 2 and 3 because you needed both negatives. Wait a minute. Yeah, it does. Positive and, wait, I wrote the wrong number down. That's awkward. That's supposed to be a 5. Now it's 7. So therefore you get x minus 2 times x minus 3 equals 0. X equals 2 and 3. Now, really quickly, in the future, because logarithms are a little bit messy, we have to be careful when we get answers. Sometimes there are things called extraneous answers. You guys hear extra in there, right? Extraneous, extra. Where it's like, hey, the math said good, even though technically the original equation would say bad. But the nice thing is for exponential functions, the domain is all real numbers. Nobody gets left out. So we're fine. Logarithms are the ones that will have answers that look right, but they're not. They're called extraneous. Don't worry, we'll talk about it in the future when we get to logs. Hey, what are we starting today? Logs. But first, let's grade. Okay, section 3.1. Any quick questions on any of the warm-ups? Going, gone. Here we go. 3.1, number 2. Transcendental. Number 4. Grab out a colored pen. You guys are already in your homework spirals. Just pick the pen. You guys are awesome. Why don't you have like a little tab in your homework spiral so you can always like just keep track of where you are? Okay. Number 2, transcendental. Number 4, natural exponential. I think that's the name for E or something, right? E is the natural number.
Yeah.
Number 10, that was like a plug and chug to your calculator. That wasn't bad. Number 14, you were supposed to be talking about the graph. Oh, never mind. No. This is the book trying to explain why it made its match. You were just matching. Number 14 was C. Number 16 was D. 14 shifted up. 16 shifted left. No, right 2. They just gave all kinds of extra information because they're the book. Number 24. Did you guys get 7? What was the key to making 16 into 2 to the 4th? Really, really good mental math? Maybe. Or what else could you do? Not everyone's a mental math person. That's okay. Use your calculator. Or just do the factoring tree. Really quickly, I just need to know how you guys were trained. If you were breaking down 16, how many of you would have done it something like this with a factoring tree? And it would have been 2 to the power of 4. Yeah. How many of you guys would have done 2 to the power of 4? Wait, so you just mental math it and you know magically it's 2 to the power of 4?
Yeah, I just don't remember a lot.
Okay, not everyone's a mental math person. I graded your test this weekend. Come on, you have to have a way to do this. It's because I love you. It's true. I've been teaching 12 years. Not everyone's a mental math. Yes, except in every other class someone was absent. Oh, you guys actually know that? I think I would do it. As a chaplain, that's it. But yeah, I'll throw them in RunWeb tonight so you guys can see it. So if I gave you 256 and I wanted a 2 to the power of, you would just pop it off?
Is it 4?
Okay, for those of you that it's too big, and if not, then I'll keep on going and I'll keep having fun. I mean, I'm doing powers of 2, so they're easy. But you have to have a way to break it down without your calculator, right? What did you learn? The tree, the box, or something else? What did you learn? Did you literally always just use your calculator?
No, tree. Taught us trees. Nobody told me that. Yeah.
Memorize powers of 2 and 3 and 8 and 7 and...
Oh, yeah. You guys know.
Memorize powers of 2. And then trial.
Okay, this is fun. Yikes. Okay, then fine. Who has seen the tree before? Thanks. Who has seen the box method before? Okay. We have seen more the tree than anything else, and we'll just keep going. Number 34, you were supposed to graph. He was supposed to shift down and left, and you guys should have brought the horizontal asymptote along with it if you were doing it by hand. Number 52, the ease, no stress, solve, 5 times. Anything else? 76 was a bonus, though, and the key to the bonus was knowing that addition of exponents comes from multiplication of like bases. It's doing the exponent rules backwards. Then all of a sudden I can go ahead and say, oh hey, I know who that is, it's 64. And I can rewrite this as a base of 4 instead of a base of 2. Muy interesante. Really quickly, as we go through this chapter, guys, there are going to be some basics that some of you know really well and some of you don't know so well. I'm pulling something up on the screen that I showed. Maybe I shouldn't show people's quizzes. There we go. Some of you would ace this book, and some of you would fail at it. Why? Well, hopefully most of us, just kidding, some of us answered it wrong last week, would know that anything to the 0 power should be... but some of us forget that one too. Maybe when you're looking at expressions, this one probably isn't one that you guys will get messed up on, but I can show you a few other ones if I wanted, just to try to trick you. Be careful. Remember, if there are no exponents written, the understood exponent is always going to be 1, which is one of the reasons why in the warm-up today we could not put that 2 and that 3 together wherever